This is a session of electrochemical machining, in short ECM. In this we are going to cover the principle, working and equipment of ECM. Electrochemical machining can be considered as reverse of electroplating process. In ECM, anodic, that is positive workpiece, react with negative ions of electrolyte and dissolves or disintegrate as salt particles. These negative ions are created by the electrons applied by cathodic tool. The shape of the tool is important as it is mirrored on the workpiece. High velocity electrolyte flushes out these salt particles and leaves the machine surface. For the working equipment of ECM, we have different components. Firstly, tool, which is connected to the negative terminal of the supply, therefore cathodic. It is equipped with servo control for vertical motion of tool for controlling gap. Then the workpiece, which is anodic, that is connected to the positive terminal of the supply. The power supply must be capable of providing high current in the range of 50 to 40,000 ampere at the voltage of 5 to 30 volts. Electrolyte is stored in electrolyte tank. It can be NaCl plus water that is provided to tool and workpiece gap through motor and pump and passes through the filter and pressure control arrangement for necessary controls of velocity and pressure. The gap is maintained to be 0.05 to 0.07 mm and the velocity of electrolyte is 30 to 60 meter per second. Let's see what happens between the tool and workpiece gap. The electrons from the cathodic tool create negative ions of the electrolyte. These negative ions tend to react with the positive workpiece ions. This reaction together form salts, which are flushed out by the high velocity electrolyte. This salt deposit as a sludge in electrolyte tank. This leaves the clear machine surface behind. That's it for ECM. Thank you for watching this video.